No. However, you have a good point. There are functions with the horizontal asymptotes. And they look like this. Let's say on this side is y equals 3. On that side is y equals negative 3. So it is possible. We're not going to look at those functions in this class, however. Not to worry. No. So I know that x cannot be negative 1. I know that x plus 1 doesn't go away with another factor of x plus 1 from the top. What does this say about the function? That, what do we write under here? That x that's it. That's all I want you to say. Because I have to put the information in the chart so I don't mess it up. Once I write that, what do I have to present left and right of the vertical asymptotes? Infinities. Right away, infinities. Now, yes, awesome. I need to choose a number like negative 1.1 and negative 0.9. I will plug them in. You can use a calculator for this if that's what you want. But I will plug them in the factored form. Okay.
Negative on the left, positive on the right.
So, negative 1.1 plus 3. I only want the sign.
Positive.
Negative 1.1 minus 3.
Negative.
Negative 1.1 plus 1.
Negative.
Good. So what is the sign on the left-hand side? Very good, because we have two negatives. Let's plug in negative 0.9. Negative 0.9 plus 3.
Positive.
Negative 0.9 minus 3.
Negative.
Negative 0.9 plus 1.
Positive.
Sign on the other side. Good. Please plug in 0. Very good. And now please tell me, when is this function 0 to find the x-intercepts? When is the ratio 0?
When both numbers top and bottom are the same. Plus or minus 3.
Yes, when the top is 0, right? A fraction is 0 when the numerator is 0.
So you know I need to.
So negative 3, 0, and 3, 0. Nothing new. This is what is new for this function that we have not seen before. And we talked about it at the beginning of the class today. The degree of the top is
2.
The degree of the bottom is 1. The quotient, when I divide, I'm going to have to use a long division or synthetic division in a minute. What will be the quotient?
1.
Which means degree 1. Awesome. Which means when I talk about degree 1, which type of function? Linear. That will be the slant asymptote. If the quotient has a positive leading coefficient, the slant asymptote will look like this. If the leading coefficient of the quotient has a negative leading coefficient, then the slant asymptote will look like this. This function will not have a horizontal asymptote. Instead, we'll have a slant, which will be the quotient of the division that we're going to work on in a minute. So what will be the end behavior of the function if it has a slant asymptote like this? What will be the end behavior? From
Negative infinity.
That's positive.
Oh, positive.
From positive infinity to negative infinity. What if the slant asymptote is like this? What will be the end behavior?
The opposite.
The opposite. But we have to determine the slant asymptote. And that will be the end. I'm sure you noticed that type 3 is a little bit more involving than the previous ones. So let's use a synthetic division. What goes in the box? Perfect. Now please dictate the coefficients. Yes? Awesome. Very good. Perfect. Great. Good. So I'm ready. I copy 1. Negative 1 times 1. Perform the operations. Negative 1 times negative 1. And I box in.
Negative 9. Oh.
Good. Can anyone give us the quotient. Quotient equals slant asymptote. Y equals, can anyone give us the quotient? Thank you. This is the slant asymptote. The remainder doesn't mean anything. No, because -8 over x plus 1 at infinities will approach 0.
Okay, got it.
So, I'll go back. I would write y equals x minus 1 slant asymptote. Since the slant asymptote has a positive or a negative leading coefficient? Positive. It means that it will look like this. So then what is the end behavior of the function? If the function must follow the asymptote, like it did with the horizontal, it has to follow the slant asymptote now. How? From
Negative infinity to positive.
That's all I need. So let's make sense of the information we have, and let's graph it. From approaching the slant asymptote, crossing the x-axis at -3, 0, and approaching the vertical asymptote on the left-hand side, going to positive infinity. One more time. From approaching the slant asymptote at -infinity, crossing the x-axis at -3, 0, and on the left-hand side of the vertical asymptote, going to positive infinity. On the other side, from -infinity on the right-hand side of the vertical asymptote, crossing the y-axis at 0, -9, crossing the x-axis at 3, 0, and approaching infinity, approaching the slant asymptote towards infinity. One more time on this side. From the left-hand side of -infinity, the left-hand side of the vertical asymptote, crossing at 0, -9, the y-axis, crossing the x-axis at 3, 0, and approaching the slant asymptote towards infinity. That's it. When we graph functions with asymptotes, we have to graph the asymptotes first. So what would be the first asymptote that I have to graph? Awesome. And now I have to graph the other asymptote that is a line when x is 0. When x is 0, how much is y? It's a line, I have to find the x and y intercepts. When x is 0, how much is y? Very good. When y is 0, I move -1 to this side. When y is 0, my x must be?
-3.
-3 minus 1 is not 0.
Plus or minus 3.
So when this is 0, what exactly? When this is 0, 1 minus 1 will be 0. So here it is. Y equals x minus 1. So now I'm looking at the chart again. -3, 0. So this is -1, -2, -3. From approaching -infinity, I have the unit as, this is too big, and okay, I'm going to say that -3 is closer, because I'm not going to be able to show you what I need to show you. So I'm going to say that this is the point. If I use this, which I should, then I need to extend this and show you like this. We're going to graph it with a graphing calculator in a minute, so you will see what happens. So -infinity is here. 0, -9. I'm going to say it's somewhere here. It's not, but then I have to graph it again and make it smaller. And 3, 0, and approaching infinity. So this is the function, type 3, x squared minus 9 over x plus 1. Let's punch it in the graphing calculator. What other function do I have to punch in? Yes? Say it again.
Would you do that x to the negative 1 or no?
So what function do I have to put in?
Or no, x minus 1.
Exactly. The calculator will not graph it on its own. Yes, that's the slant asymptote of x minus 1. So now careful, it's coming. I'm going to use the standard, although the standard will not be very good because of that -9, so I have to change it. Okay, so x minimum, yeah, -5 to +5 is good, with a scale of 1 is good, but the y minimum, I'm going to say -15 to +8 with a scale of 3. Here it comes. Here it is. Now the slant. So it crosses at -3, 0, approaching the slant asymptote -3, 0, and going towards that vertical, x equals -1 towards infinity. This is x equals -1. So now it's coming, crossing at 0, -9, crossing again at 3, 0, and approaching the slant asymptote towards infinity. So I know I still have a few more minutes, so all I wanted now is to show you some applications. Because this is all nice, wonderful, but what is it useful for? A lot of applications here with rational functions. So let's look at problem. Any questions for me, please?
So again, the
Yes.
vertic and slant asymptote, I mean, for type 3, it's always a slant, right?
Yes, there is no horizontal.
It's always a slant, and then
Yes.
you find that by doing.
Only type 3 has slant.
And you find that by doing the synthetic.
Long division or synthetic
long
division,
synthetic.
whatever works.
Right, but for our cases, we do synthetic, it's always, no.
Only if the denominator is x plus 5 or x minus
To the
3.
first degree.
But if it's x squared plus 5x minus 3, you cannot use synthetic division.
Right, okay, in that case.
So you only need to determine the quotient. The quotient has to be aligned. That's the requirement, that the degree of the top is exactly by 1 unit higher than the degree of the bottom.
If it was like a square, though, would it be a parabola?
No, you cannot graph that without a calculator. No.
Okay.
And that will not have a slant asymptote,
Okay,
because the quotient will not be aligned.
right.
The quotient must be aligned. And that's why degree 5 over degree 4 will give us the quotient of a line.
With a line, right.
Degree 3 over degree 2 will give us the quotient of degree 1,
Okay, okay.
which is what it's going to be a line. That's how you remember the type 3. Good, perfect question, actually. Thank you. You've done a lot of studying this. No? Okay. Good. On page 428, I'd like to look at problem 101. 428. We're given a function f of x, and I will ask you what type of function it is in a second. 6.5 x squared minus 20.4 x plus 234, everything divided by x squared plus 36. It says models the pH level. So this gives the pH level.
Can you turn the screen on?
No, I'm sorry. Thank you. Sorry. Okay, models the pH level of the human mouth X minutes after a person eats food containing sugar. X minutes. So a lot of effort, a lot of doctors, a lot of patients, and a lot of mathematicians put their brains together to come up with this. They looked at a lot of data. They measured a lot of people. Okay, their pH level X minutes from giving them a piece of sugar. Okay, a lot of effort was put into this. Okay, what kind of function did they come up with that models, according to them, that models the pH level X minutes after a person swallows something with sugar? What type of function is it?
Rational.
Thank you. It's a ratio. It's a polynomial at the top, a polynomial at the bottom, and definitely x in the denominator. Excellent. Rational. Good. Can you tell me what type? Oh, type 1. I'm sorry. Type 1. Same degree over same degree. Will this function have a slant asymptote or a horizontal asymptote? Yes, you do.
No, really, I don't. You kind of lost me there.
What did we say? Which was the only function that has slant?
I guess type 2. 3.
Yeah. The other two have horizontal.
So then this won't.
This will have a horizontal.
But it's the same over the same.
Yes.
Oh,
but
horizontal. Oh, okay.
It's the leading.
It won't have slant, right?
It will not have a slant. So what would be the horizontal asymptote then?
Plus or minus 6.
Not plus or minus. It's the same horizontal asymptote. We are not looking at functions with two different horizontal asymptotes. So it's the leading
36.
coefficient over the leading coefficient. So what is the horizontal asymptote? 6.5. Exactly, 6.5. I'm going to copy the graph. They're giving us the graph here. So what is the horizontal asymptote again?
6.5.
Good. 1, 2, 3, 4, 5, 6.5. So y equals 6.5. We're not looking at the negative number of minutes, of course. So this is x in minutes. And this is y, which is the pH level. So they already graphed the function, and they got something like this. Okay, so first question here. Use the graph to obtain a reasonable estimate to the nearest tenth of the pH level of the human mouth 42 minutes after a person eats food containing sugar. So 42 is somewhere here. How will just tell me how will you determine it?
What was the question again?
What is the pH level 42 minutes after they get something with sugar?
So 42 into the equation.
That's it. Or put 42 in the equation. That would be the easiest. However, the graph is the same with a function. I'm assuming, right? So sometimes they plot all the points and then they connect. And the function they come up with may not be identical with the graph we look at. So they didn't say that. So I'm just telling you. So yes, so f of 42 will give us the pH level after 42 minutes, and we can do that in a second. It says use the graph, which will be an estimate. After part B, and we can plug it in. After eating sugar, when is the pH level the lowest? How many minutes after I swallow something having sugar? 6 minutes. Right here. So this is part A, and we'll determine in a minute. And part B, minimum at x equals 6 minutes. Minimum pH level. Use the functions equation to determine the pH level to the nearest tenth of this. Okay. So we're going to find f of 6 in a minute. Part C. Yes. Yes, go ahead.
It's actually nothing mathematically. I was just gonna. I was thinking about griping that. Oh, you know, if the pH level of your mouth was actually at 1, you'd pretty much be dead, or want to be dead, because you know it's very acidic. Again, nothing to do with that.
Okay.
I was.
The reason why I don't want to determine these right this moment is because I want to put the function in the calculator and determine all of them at once. Okay, so part C, according to the graph, what is the normal pH level of the human mouth? So let's analyze this graph for a moment. So I take a piece of sugar in my mouth. My pH level is 6.5. 6 minutes later, it drops to whatever, let's say 1. Okay, and then Slowly, it goes back to normal. So then what is the normal?
6.5.
6.5. So the normal pH level, 6.5. Part D, what is the equation of the horizontal asymptote? You already gave it to me. Describe what this means in terms of the mouth pH level over time. What does the horizontal asymptote of 6.5 mean? I already said it, but what would you say again? Eventually, the pH level in the mouth will go back to normal, and the normal is 6.5, or close to it. Use the graph to describe what happens. We already did. What happens is, I take sugar, my pH level is 6.5, 6 minutes later it has dropped to, let's say, 1, we didn't determine it, 1, and then eventually, assuming I stopped eating sugar, right? I just took one piece, and then it will continue, or it will eventually get back to normal. So now I would like to determine those values. So in y equals, I clear everything, and I put in my function, which again, parentheses 6.5, and it was x squared, and minus 20.4x, and then plus 234, and close the parenthesis and divide by x squared plus 36. And then I go to second and table, and I plug in what I want. And I want 42, and I want 6. 42 and 6. So at 42 is 6.024, and f of 6 is 4.8. Any questions for me?
Is 6
Yes.
not a vertical asymptote?
Very good question. When does a rational function, excellent. When does a rational function have vertical asymptote?
It goes all the way down to infinity. Well,
But that's not the main reason.
Well, if
When
the graph doesn't actually reach that point.
the denominator is 0. When the function is undefined. When is x squared plus 36 0?
Oh, it's plus 36. I thought it was minus.
Never.
Okay,
So
okay.
the answer is
reason.
never.
Sorry.
So that's why this function, it happens that it does not have vertical asymptote.